Okay, guys, I do want to mention we are recording this. I just started recording, but this is not going to be publicly available. It's only available to those who have the link on the YouTube site. But definitely wanted to mention that. And like I said, we had 20 people last night, which was great. And now we have two now, so I think almost everyone in my section came on, which I'm good. It's definitely a record for me. So the plan for this session is this is more of a theoretical lecture. I have a couple topics that are somewhat related that I'm going to go over using a PowerPoint. And just at the end, if you have any questions, let me know. One issue that we discovered yesterday is if I drop off, I might not even know that I dropped off. Because on my screen, I'm on my laptop, and on my screen is just is the PowerPoint full screen. So if someone's trying to tell me something, I might not hear it. So Rob, I'd ask you to text me. I got my phone right here next to me, so that's how I'll know if you guys can't hear me. So let me get this PowerPoint open, and we'll go through this quickly. Okay, let me share my screen with you guys. Okay, so do you see my intro slide?
Yes.
Okay, great.
Yes.
So like I said, there's a couple different topics. I'm going to be going over the technology evaluation process, the concept of cost versus price, the concept of redundancy, and the concept of risk and risk management. The reason we're doing the technology evaluation is because your exercise for next week, you're actually going to be doing a technology evaluation. So I'm introducing it now. So let's jump right into that. So why do you do a technology evaluation? The main reason is when you have a problem, and again, I've hammered this into you guys, you always start with a problem. When you have a problem that you're trying to solve and you're looking for solutions, and it involves generally a piece of technology or some equipment, doing a technology evaluation is a very good way to build an argument and make a case, especially when we're talking about spending a lot of money. Some of the reasons it's good is it's generally uh, an objective way of doing things. It looks at both cost and price, and it's just a solid way to lend credence to your argument that you want to do something. As a manager, as a boss, when someone comes to you and shows that you've gone through a structured process with multiple people inputting, that's a lot better. That's a stronger argument than you going into that office and saying, we should buy this piece of equipment because I think it's a really good idea. So again, that's what we're talking about. A technology evaluation is just generally a structured process to determine what piece of technology would be best for that problem. Now, there's other methods of doing this. You can do what's called a Delphi, or do expert opinion elicitation, or just have a strictly independent analysis. But those are ways to do it, and I'm just kind of showing you a real simple way, a very common way. So if you take a look at this spreadsheet, I'm going to walk through an example using the spreadsheet. This spreadsheet is provided to you for your exercise next week. This is just essentially a screenshot of it, but the one that you'll be using for your exercise is a dynamic spreadsheet in Excel. So for example, this red column actually turns a color when it reaches 100, and it sums up everything for you. So basically, in a very generic sense, we've determined a problem. The first thing you want to do is determine your evaluation criteria, which is under the criteria column. For this example, I picked 5: reliability, cost, training requirements, maintenance, and compatibility. You can pick as many or as few as you want. But yeah, you really should pick the categories that are important to you or important to the problem. And then the next thing you do is you determine the relative importance, which is their weight. So for example, in this example, compatibility is extremely important, so we ranked it 40% of the total. Cost and reliability, not so much, 10%. So that will be reflected in the overall score. But the key are these first two columns. This is how you evaluate the problem, your criteria and your ranking. So you should pay a lot of attention to how you develop that. You should have probably multiple people develop it, and there should be some consensus on how you get to these numbers and categories. The next thing you would do is actually provide rankings. So you'd pick, for example, here we picked 3 different technologies, and technology 1 gets a 10 on reliability and an 8 in cost. Compare that with technology 3, gets a 7, indicating it's not as reliable, but its cost is 3, so we can assume that the cost is much lower. So generally what you want to do is you want to go through these rankings. It's best to have multiple people do the rankings, and then you can aggregate it and average it. This is just one example, but ideally you have multiple people evaluating the same thing, and with multiple pieces of data, you get more of a consensus result. So for example, in this example, technology 2, has the highest score. So we can, we'll make the case that technology 2 best suits our needs overall for whatever application. And again, this is a very generic example, and you determine the criteria and the weight, and even the ranks. For example, for cost, in my example, the higher the number, the costlier the the technology is. So just keep in mind that it's user defined. There's no standard and there's no rule on how you define it, but that's important that you do define it and you clearly define it and have a consensus. So that's basically it. You're going to be doing this next week as a small group project, and what I'm going to do is give you a scenario and provide you this spreadsheet, and you have to essentially come up with some solutions and do your ranking, and then try and make a case on why or why not you would suggest the given technologies. Okay, next concept is cost versus price. So in an economic sense, cost is your sum of all inputs. I'm going to use my iPhone here as an example. My iPhone I bought for $600 at the store, and that was the price that I paid for it. However, Apple is certainly making money off that, so we can assume
Just try to work together. I know sometimes life can.
Can you guys hear me?
Yes.
Yes, we can.
Okay. I don't know. We had the same problem as yesterday. I'm going to log on and log off.
Session rather of these particular round, but if you click on Adam's little icon on the bottom, you will definitely get to his screen, and that's helpful when it comes to screen sharing time.
Okay.
Yeah, thanks, Rob. So where did what was the last thing you heard me say?
We were talking spreadsheets or the worksheet and scoring and how that ranking is
Okay.
Occurs.
Okay, so the point is that is your exercise next week. You're going to use that exact spreadsheet, and you're going to be given a scenario, and you have to pick some technologies. You have to pick the criteria and evaluate it. So I'm this part. I'll share my screen with you guys. Thanks for alerting me to that. Okay, you guys, is my cost versus price slide up?
Yes.
Okay.
Yes.
So there's in an economic sense, the cost is the sum of all your inputs. So using my iPhone as an example, the cost to Apple to make this, let's say, is $400. However, I'm paying $200 extra, so I'm paying $600. Obviously, that $200 is the profit that Apple's making. So the price is what I'm willing to pay, and the cost is all the inputs. However, in the sense of technology evaluation, cost and price has a slightly different meaning. Cost is actually the sticker price. So cost is, that's $600 for my phone. But the price is actually all the additional components. If I have a staff of 10 and I buy 10 iPhones, that's $6,000. That's great, but I didn't figure, how much it costs to train these people. I didn't figure how much it costs to set up my help desk. And then maintenance and disposal are factors too. So the cost is, not $600 for my phone, but it's actually $1,000. So the point is when you're evaluating technology, you have to look at the life cycle of it. You have to look at how much the equipment costs, for example, how much it's going to cost to train, even disposal. Some equipment, requires special disposal, like if it's got a big battery or something. So, for example, you might have to figure in cost for disposal. So that's the point, is when you look at something and you do an evaluation, don't just look at the price that you're paying for it. Take a holistic view and try and anticipate all your future costs. It's very important. Okay, next concept is redundancy. So again, redundancy has kind of two meanings as well. In the business world, redundancy is waste. Redundancy is something that you seek to cut out. Redundancy is something that you eliminate to save money, and to save money and make more money. So that's in one sense. In our sense, it's different. Redundancy, is actually very important in our industry, and we actually seek to maintain redundancy and not eliminate it. Obviously that spans, different activities within emergency management. Obviously communications is probably the most common application, but redundancy is a very important thing, and I'm just going to go through a couple examples. In an airplane, they use the aerospace industry, and airplanes generally use a philosophy of triplicate redundancy. For example, on any commercial airliner that you have flown, there's the way it moves, it moves its ailerons and its flaps. And there's three ways to move that. One, they have a digital system that the pilot can press a button on a computer and it can move the control system. Secondly, if that fails, they'd have a hydraulic system that they can pull a lever and it'll control the airplane. And then thirdly, there's probably a manual system where they can actually physically move the components of the airplane that need to be moved with another lever that's directly moving that component. So there's three ways. There would be three ways on a plane to steer it. And that's important because it's a very critical application, and it warrants the investment and it warrants the redundancy. And the basic idea is redundancy is a function of risk, right? So the more risky something is, then the more redundant it's going to be. So for example, flying in a commercial airliner, there's a lot of risks of something bad happens, everybody dies. So that's clearly an application where we'd focus our resources. Redundancy costs money. We know that. So the key is you want to focus your resources where it most matters. So the next topic is risk management. So we are going to I'm going to show you a way to think about how to manage your risk and really where do you put your money, where do you maintain your redundant systems. Okay, so do you guys see my nice purple chart? Okay, so this is a risk framework. My definition, and a very common definition of risk, is probability times impact. Probability is probability of occurrence. Impact is is impact, but how in our context is how bad is the damage, how many people are affected, so on and so forth. So if you see on the x-axis, the bottom horizontal axis, it goes from low to high. And then on the vertical axis, the y-axis, again, low to high. So the y-axis represents the probability of occurrence, and the bottom horizontal x-axis represents the impact. And in this context, we're talking about emergencies and disasters and so on and so forth. So to give you a couple examples, in Washington, D.C., we have thunderstorms all the time, so especially, in spring. So as you can see, I placed it in the, it's high up on the probability of occurrence. It's near the top. But at the same time, a thunderstorm in D.C. is, might slow traffic down. It might take down a tree or two. But generally, it passes and no one, thinks twice about it. So it's a pretty low impact event. So that's why that's in that quadrant. Another example is an earthquake. A San Francisco earthquake. That we know that's going to happen. We know it does happen regularly. There's earthquakes in the Bay Area weekly, small ones, and we know that there's big ones from time to time. So I consider that a high probability event. But also, it's a very high impact event. A big earthquake in San Francisco could devastate the city. It could actually devastate the whole state of California and even have implications for the whole country. So the impact of a large earthquake in San Francisco is both probable and high. The same could be said for a hurricane in Florida. Florida is a hurricane magnet. They get them all the time. And, there's a lot of people living, for example, in the Miami area. And when that hurricane hits, it can have national implications. It can displace up to, several million people. So I consider that, again, a high probability, high impact event. Giant asteroid, wiping out the city of Washington, D.C., or maybe the planet. Yeah, that would be devastating, obviously. We've all seen those movies about the Earth being destroyed. So I pretty much consider that the highest impact event possible. But what's the probability of that? Based on my knowledge, it's probably happens once every billion years. So clearly, that's a low probability event. So the whole point of this is to look at these quadrants. So as you noticed as I was talking, there's really 4 quadrants. And if you look at the upper right one, which is titled High Impact, High Probability, this is where you want to focus your resources, right? You don't want to focus your resource in the low impact, low probability. You really want to focus high impact, high probability. That's where you have the highest chance of something happening, and if something happening, it's going to be pretty bad. So when you're thinking of in our business, this risk management framework can actually be used in many different ways. But in the concept of redundancy, when you're talking about where do you invest your money, where do you provide redundant systems, where do you do a lot of planning for a given scenario. If you look at it in this way, this will really help you to prioritize and make decisions on where you're going to put your money. Secondly, you should always keep in mind what are called black swan events. There's actually a book and that coined the term, and it's a great book. But it basically are these events, and I would consider Hurricane Katrina one. I would consider the earthquake in Japan and the meltdown of the Fukushima reactor one. Are these low probability but extremely high impact events. And again, it raises a bit of a conundrum in that I'm telling you to focus your efforts on high impact, high probability, but at the same time you always have to keep an eye out for these black swan events. It gets a lot of people in trouble when you ignore these and you don't anticipate them. And listen, I'm not saying you should treat them equally as the upper right quadrant, but always keep in mind that those high impact, low probability events are lurking, and you should always at least understand what they are. So again, just to wrap it up, this is a risk management framework. It's a real simple framework. It's very commonly used, and you can use it for a whole host of problems. So when you do your as we go on throughout the class, keep this in mind. Okay, so on.
If hello, you're
Yeah.
back.
Okay. Did you lose me again?
I did.
Where?
So we were looking at the chart and just starting to describe the risk assessment and the 4 quadrants.
Okay. Bianca, did you lost me too, and Kim?
Yes. Yeah.
Okay. So I was on the first chart?
Yes.
Okay.
Yes, you were on the red squares.
Okay, let me try again. Let me do it one more time. Okay,
Yep.
I'm back. So let me pull up that slide again, and we'll just wrap it up real quick.
Right. And I'm going to mute out for just a second. I'll be right back. And don't forget to click on Adam's little box in the bottom. That'll help you if you aren't already seeing the screen.
Yes. Thank you. It's very helpful.
Hey, Bianca and Kim, are you seeing my red box?
Yes.
Okay, was this the one I left on, or this previous one?
That one.
No, it was the red one. You were just
Oh.
starting the red one.
Okay, so quickly, this, as you can see, if you notice those 4 lines, it kind of creates 2 lines creates 4 quadrants, and I just want to show you, where do you want to focus your efforts? Clearly the high impact, high probability ones. That's where you want to focus your efforts and resources. And that would apply to planning, for a given disaster scenario, or where you're going to invest money in equipment, for example, communications or something like that for a given scenario. That this is just a way to think of risk, and it really what it does, it helps you prioritize, and it helps you determine what's most important, and what's where are you going to put the money, and where are you going to put the effort. So if you think in this context, this will really help you out in a lot of different situations. It's a simple framework, but you should use it in a lot of different areas, not only in your not only in emergency management, but in your life in general. The only other thing you do have to keep in mind, that bottom right quadrant, which is high impact, low probability. These are called black swan events. These are, an example, 2 examples I'll give you. I think Hurricane Katrina is one, and the second one, would be the Fukushima, Tokyo, the Japan earthquake, Fukushima reactor meltdown. These are very low probability events, but have a huge impact. And these, what happens is we tend to turn a blind eye to these, but you shouldn't. And I'm not saying that you need to focus your resources equally here, but you should always keep these black swan events in mind. Okay. So I'm done with my slides. Got through it. Yeah, and I apologize, guys, for these technical issues. It happened last night too, so I'm trying to figure out a better way to do this. But that's what I wanted to go over today. Do you guys have any questions?
No, it's pretty much self-explanatory. I mean, you explained it well.
Okay. Well, thank you.
You're welcome.
Kim, any questions about what I talked about now, or generally in the class?
No.
Okay. All right. Well, I think we're done. This was a real small group. It took us an hour to get through the same thing yesterday. Rob, do you have anything? Any closing comments?
No, not really.
Okay.
Everybody holler early and often if you have any questions on your assessment worksheet or the project as it moves forward.
Okay.
All right, guys. So take care. Thank you.
Thank you.
Have a good day, everyone.
Thanks, everybody. Appreciate it. Bye-bye.